Hello students, this lesson is about simplifying radicals. And when I say simplifying radicals, I don't mean just putting it in your calculator and getting a decimal. That decimal is an approximation. Simplifying means finding another expression that represents the same thing, not a decimal, which is only approximation. So, when you're simplifying radicals, you're going to need to know some basic square roots. So all your square roots, 1 through 10, it would be great if you could just recognize them. So that if you see 81, you're like, oh, square root of 9. Okay, so what you're going to do is you're going to look at this and you're going to find the largest perfect square, such as 81, that divides evenly into the number. So look for that largest perfect square. Such as with 75. What's the largest perfect square you can think of that goes into that? Well, 1625. So 75 is really 25 times 3. The square root of 25 is 5. The square root of 3 is uneven, so you're just going to leave it square root of 3. So first, break the number down into two pieces, then take the square root of the piece that you can. Alright, now what about when we have variables? You're going to multiply the exponents by 1/2. Why 1/2? Because square root of x is to the 1/2 power. So you're going to multiply the exponents by 1/2. Now sometimes you won't be able to take 1/2 evenly. A decimal is allowed, but it would be it's for our purposes it's better if you split the base so the exponent divides evenly. Alright, so here's an example of what I mean by that. If we take the square root of a to this power 6, well 6 divided by 2, 6 times 1/2 is 3, so that's just a to the 3. However, when I get ready to take the square root of a to the 9, well, 9 times 1/2, 9 is an odd number, not an even number. So, we're going to split the 9 to be a to the 8 times a to the 1, because 1 plus 8 is 9. Now I have a nice even number and then the leftover piece. So, 8 times 1/2 is 4. So this equals a to the 4. And then the square root of just a is uneven, so I'm just going to leave that square root of a. Alright, so if I have a to the power 5, I'm going to break that 5 down into a number that goes whole, divides by 1/2 whole, and then the piece that's left over. So I would have a to the 4 times a to the 1, because 4 plus 1 is 5. 4 to the 1/2, or a to the 4 times 1/2 is 2. So this is a2, and then I still have this 1a left over. Alright, so now in this example I have square root of 72 a cubed b to the 4. So when you look at that 72, I want you to find the largest square number that you can break up that goes evenly into 72. Alright, the largest square number I can think of is 36. 72 is 36 times 2. Now when I have an odd exponent, I need to break that odd exponent up into an even number and then the odd part. So 1 less than 3 would be 2. Okay, and then b is already even, so we'll just put b to the 4. Now I'm going to simplify this by taking the square root of the parts that I can square evenly and then leaving the other parts that don't work out evenly under the square root. So the square root of 36 comes evenly, so I can pull that out. Square root of 36 is 6. The square root of 2 is uneven, so I need to leave that inside here. I'm not going to take the square root of 2. The square root of a squared, well, to the power of 2 times 1/2 is 2 times 1/2 is 1. So that's a to the 1. And next I have a to the 1. Well, that's 1 is an odd exponent, so I can't do anything with it. We're going to leave it underneath. And then b to the 4. 4 times 1/2 is 2. Here's another example. What is the square root of 4500 x7 y11? First, let's split 4,500 into perfect squares. The first square I think of is 100 because I see 2 zeros there. Alright, that would be 100 times 45. But 45 I can break down as well. 45, 5 goes in evenly, 9 times 5. 9 is also a perfect square. 100 times 9 times 5 will give me 4,500. Now we're going to break the 7 down. I'm going to make this x to the 6, x to the 1. Alright, and the same thing with the y. It's to the power 11th, which is odd, so take it down 1 to make it 10. 10 and 1. The square root of 100 is 10. The square root of 9 is 3. The square root of 5 is uneven, put it underneath. The square root of x to the 6, 6 times 1/2 is 3. We have 1x left that's uneven. Y to the 10, 10 times 1/2 is 5. And we have 1y left that is uneven. So here's my answer, except I can simplify a little bit more because 10 times 3 is 30. Okay, the next principle is that you cannot have a square root in the denominator. Now, why can't you have one in the denominator? It actually goes back to the days of slide rule and things like that, where before they were using calculators, they had a hard time dividing by a square root like this because it is an irrational number. But now with the advent of calculators and so forth, it's actually not a big deal for us today having a square root in the denominator. However, due to tradition, we no longer, we always try to simplify that and not put the square root in the denominator. So, to make it cancel out, what you're going to do is you're going to multiply by itself again. Because x square root of x times square root of x is x to the 1/2 times 1/2. Well, you add those exponents, 1/2 and 1/2, and you get 1. So square root times square root cancels to just give what's underneath it. So I'm going to multiply this by square root of 5 over square root of 5. Okay, square root of 5 times square root of 5, and in the denominator, that actually just cancels out to give me 5. And in the numerator, I have 2 times square root of 5. And that's all there is to it. Alright, let's see if we can get rid of this square root of 3 in the denominator by multiplying by square root of 3 over square root of 3. Square root of 3 times square root of 3 cancels to just give me 3. Square root 6 divided by 3 is 2. Then we can combine the square root of 2 and the square root of 3 and multiply them together to give square root of 6. And that's the answer. So the last thing with simplifying radicals is with the conjugate. What if we have in the denominator a radical that's been added or subtracted? Well, in order to make it cancel out, you have to multiply by the conjugate. The conjugate is the exact same binomial that's already down there, except you're going to change with the opposite middle sign. So this one has a plus. The conjugate of 2 plus square root of 2 is 2 minus square root of 2. The top and the bottom by 2 minus square root of 2, because that's the conjugate. So now in the denominator, we have to use FOIL. My first times my first is 4. My outer is 2 times negative square root of 2. The inner is 2 times positive square root of 2. And the last times the last is square root of 2 times square root of 2. That cancels to give me 2. And in the numerator I have 3 times 2 minus square root of 2. In the denominator, negative 2 square root of 2 and positive 2 square root of 2 cancel out. Good. And 4 minus 2 gives me 2. In the numerator we have to distribute 3 square root of 2. And that's the answer.